Alright, I'm going to talk about the worst mass extinction in life's history. This was the Permian mass extinction 252 million years ago. To put that in context, the dinosaur asteroid was 60 million years ago. And this is 252 million years ago. So a long time. And funny enough, this is, a little while ago, like a few million years ago, would have been the anniversary, like galactic anniversary of this event, because the sun orbits around the galaxy around 250 to 225-ish million years. So a few million years ago was the anniversary of this event. Okay, so first let's set the stage. Alright, this is around the time where we have Pangea, the supercontinent that everyone learned about, or just, heard the name of. Supercontinents aren't great for life, it's, doable, but it's just not great. Because if you think about it geometrically, there's a lot less coastline, which coastline is really rich in diversity and abundance of life. Like shallow oceans are really good. And you have those continental shelves and everything, which is good for life. You have a lot less of that, okay? And you also have the largest desert in Earth's history, because water can't reach the interior of such a big continent. And you best be assured that rivers are hardly going to get anywhere close to the interior of the continent. You also have the largest mountain range in Earth's history, because, go figure, in the creation of supercontinents, you eventually have these two really big continents that crashed into each other because they formed from other continents and blah, blah, blah. So you have this, and also, you don't have separate, you don't have area and continents separated by oceans, so you have a much less diverse landscape, because it's all the same continent. It's out of the way. And it's also really hot in the interior because there's no humidity and it's just fucking sand. But anyway, the Permian mass extinction was caused by a very large volcanic event, but it's kind of impossible to truly comprehend how big this volcano was. It's nothing like anything our species has ever witnessed, or any of the ancestral species that came before us for many millions of years. This is what is called a magma plume, a gargantuan magma plume, which is, a plume of magma that comes from the core of the Earth itself and seeps through the mantle over millions of years until it breaches the crust in the Siberian traps. And this isn't a very large volcanic eruption. No, this is a lava flood with volcanoes and lakes and oceans of lava stretching far beyond the horizon. You could travel 1,000,000 miles and never see the edge. And endless eruptions and lava gushed out for millions of years. Mountain ranges would literally burst, like bubbles. And the amount of lava that came out could have covered the USSR in lava 2.5 miles deep, or the entire Earth 20 feet deep. But the fact that a mid-sized continent just got submerged in lava and turned inside out isn't even close to the worst part, um, because it was located in an extremely unlucky spot. In the last age, the Carboniferous, forests and plants were growing at an extraordinary rate and proliferating faster than plants could decompose. So these lakes of decomposing plant material just kept rising and rising and rising for millions of years. And now those forests are most of the fossil fuels that we find today. And this lava flood happened to be rising right underneath the biggest coal seam in Earth's history. This was about as wide as Brazil and 12 miles thick on average, of extremely flammable purified carbon. Before any lava reached the surface, the ground underneath their feet just exploded. Like, but the complete ignition of a large country still isn't even close to the worst part yet. As these, huge amounts of carbon is burnt and making carbon dioxide, and also these titanic amounts of volcanic aerosols, reaches the atmosphere, which is not great. We in today's world are very worried about a change in carbon, um, from around 300 parts per million to 412 parts per million, which is causing the climate change that we see today and will see for the next few hundred years. This was a rise from around 280 parts per million to 20,000 parts per million. If we were to burn everything we could find, every fossil fuel, every forest, every plant and animal, we would emit about 5,000 gigatons of CO2 in the atmosphere. This would more than double that. All right? And one of the immediate effects would be, obviously a global warming, but that would be very short-lived because of the amount of CO2 was so great that, once it built up over a few thousand years, it would be so much to, just straight up block light from entering the atmosphere, you know. Instead of bouncing around in the atmosphere, it would just block it from entering, or the visible light spectrum, which is used by plants for photosynthesis and, dramatically cools down the earth, so you have an ice age. And then eventually, after millions of years, when that, carbon finally gets sequestered by acid rain falling down and weathering rock and then getting um, into the oceans and getting like covered in ocean sediment and locked in the ground, you would begin to have a global warming again, which, you also need coastline for, this process of carbon sequestering to happen to get it out of the atmosphere, and Pangea makes that, take much longer. But you know, this global warming, would get so bad that on land, the average temperature was like year round was raised to 140 degrees Fahrenheit on average. That's like, well, a little bit hotter than the lowest setting on your oven. And that's not even that's average on the planet. If you go anywhere closer to the interior of the Pangea, it gets much, much hotter. And that's just the air temperature, not even to mention the ground temperature, because you best believe this sand is cooking at hundreds of degrees Fahrenheit. Like hundreds of degrees. It would melt your shoes. Like just of touching the sand. Like is bad. Um and a much more immediate effect than um this swings in climate temperature would be ocean acidification, which is a fun one because when carbon dioxide reacts with water, what happens is it forms carbonic acid. What carbonic acid does is it eats calcium. I wonder what uses calcium. Nails, hair, bones, shells, teeth, like all of these things, scales, just, have just slowly start to malform and misshapen, then contort, and then just stop growing at all. And all of life that uses bones are these fleshy piles of, malformed organisms. It's really bad. And there's also some other very important molecules in like brain functioning of fish, and it's really bad. Calcium is very important, and that's why in today's oceans, uh, coral reefs are suffering really bad because that they make their you know structures that hold all the microorganisms, because they're basically structures of microorganisms that do all the metabolism and stuff for them. They just fucking melt. um yeah. And the oceans at the height of the global warming, the the sea, like surface temperatures, would have reached 104 degrees Fahrenheit, which is above boiling. Which, you know, it wouldn't be doing the actual like boiling you see in a pan because salt in the water raises the boiling point. That doesn't make it any less dangerous for life, though. Anything remotely close to the surface would be cooking. They're the complex proteins that make up life would denature and cook and boil. And also to get a sense of like how this like carbonic acid like feels, not just like the bone mending and dissolving of your skeleton. uh like like a it would carbonate like a soda, except much worse. So imagine on all of your, you know, internal facial orifices, your gills, your eyes, your ears, your nose, your mouth, all of that constantly feeling that burn of the carbon on your, that you feel on your tongue when you drink soda, but much worse on your eyes and gills, and it's bad. And because fish breathe in water, you know, your lungs pretty much. It's painful. And to further make things worse for the oceans is nutrient um, booms. Now you would think, oh wait, nutrients, isn't that a good thing? Adding more nutrients to the environment? No, maybe in like very small increments, controlled. But when you add a bunch of nutrients, like, you know, nearly everything in the ocean, dying, um, and these, volcanic runoffs into the ocean of all these minerals and stuff, you get algae blooms, which, they're the first things to get to the nutrients. And they bloom and, form these huge mats across the ocean, and then they die. And that decomposing process sucks up all the oxygen. So everything in the ocean is now suffocating because there's so much nutrient influx and so much algae just blooming and dying. And this is the same thing that happens in the Gulf of Mexico pretty much every year because of um, all the nutrient runoff from agricultural waste. And every single year, you see a fuck ton of fish, as far as the eye can see, just floating at the top because they suffocated. Um, it's really bad. And you've also got a huge food chain collapse because plankton require life, or I mean, plankton require sunlight from the visible spectrum, which is gone during the ice age. Um, and Plankton are the basis of the food webs of pretty much every ecosystem on Earth. You take that out, then everything collapses. Um, and also, plankton that have little tiny shells are also going to be dying because of the acidification. It's not a fun time. And, oh, and I forgot to mention the, uh, the oceans are also chock full of hydrogen sulfide, um, from all of this, like, you know, runoff from volcanoes, which is also very bad because that's a poison for life, for everything except for green sulfur algae, which needs some pretty rank conditions to survive. Or not algae, bacteria, green sulfur bacteria. These guys produce, their environment, like, you usually find green sulfur algae in like Yellowstone, those like little lakes where the like what are they called, the geysers, those little volcanic little lakes with all the like colors from all the different bacteria that live in there. Oh, they love that shit. That's their natural habitat. And in the fossil record, we see these layers that, you know, show us that it was chock full of these bacteria that normally live in hydrothermal vents, but they're spread across the ocean, which gives you an idea of the conditions the oceans are in right now. And these bacteria also produce, um, a lot of other worse poisons. So you've got like the oceans are this bacterial algae sludge of boiling and bubbling with noxious fumes burbling to the surface at 104 degrees Fahrenheit, and suffocating without any oxygen, and brutally acidic. Not good, just say the least. Not at all good. And the uh, the planet also saw a surge of halogenated butane methyl bromide and methyl chloride. And these, if you don't know chemistry, I forgive you. Chemistry's, a lot. But these chemicals from the volcanic aerosols pretty much just sear the ozone out of existence. And the sun that you can no longer see becomes a deadly laser with ultraviolet radiation still not being absorbed by carbon dioxide. So during the day you see like this just kind of red haze, and at night it's just dark. But you don't want to go out during the day because the whole globe saw a spike in radiation by like 5,000%. So a lot of cancer. And at the poles, where the magnetic field is a lot weaker because it's the poles, it was a spike of about 500,000%, which used to have very less forests and stuff, which, for many different reasons is fucking gone. And, and, the planet also saw a surge in like uh, mercury in the air and other highly toxic metals and chemicals from all these volcanoes. And it's really bad if you couldn't tell. And we're still not done. um, like just trying to breathe in this air on land, like with these extremely toxic metals and lethally acidic water vapor and toxic gas and noxious fumes from the oceans, and and any river that once was is gone. Just these, you know like evolved from a river to just sludge to just gone. There's no more rivers on Pangea. The very few that there were are gone. And then when you put in the like when we try to figure out the weather by putting in these um like environmental conditions of the earth that the earth is in, the computers start generating hypercanes, and with wind speeds of over 500 miles an hour, about the size of the entire west half of the US, which, for context, is much bigger than any hurricane we've ever witnessed and 200 miles per hour faster than the fastest hurricane on record. These are radioactive, toxic, acidic, poisonous hurricanes, and the wind alone would rip your skin off and whittle down your skull before you had enough time for the signal to reach your brain. And these hurricanes are so massive and so fast and powerful that they would cross entire continents without stopping and until they reach the ocean on the other end and fill back up again. And so these hurricanes, these single storms, would last for thousands of years. This is something you would find on a very small gas giant. Like nothing that's supposed to be on Earth. And this is all because of the superheated water and the superheated air. And like no place is safe, not even like the deepest part of the oceans, because any oxygen that was in the water is gone, and even if there was oxygen, the heated water destroys the oxygen circulation process, so the deep oceans are suffocating no matter what. And all of this carbon dioxide it gets absorbed by equally as much in the air as in the water, so it's just stuffed all the way down to the bottom in this acidic, it's bad. Like at the end of this, 95% of all species disappeared from the earth. And about 90% of everything that was alive is no more, including microorganisms, which, in context with the second worst mass extinction on Earth, 85% of all species went extinct, but only like 60% of everything that was alive was dead. This was 90%. This is, a once in a billion years event. And what's also even like more just horrifying is in the fossil record we find stromatolites from this time period. Now, if you don't know what a stromatolite is, it's after, when you have all these microorganisms, when they die, they sink to the bottom and build up, and over millions of years, they form these mounds that, slowly turn into limestone. So you've got these mounds of these colonies of millions of years worth of microbes that build up into these rocks, kind of like stromatolites, I just said stromatolites, kind of like stalactites, but with, microorganisms instead of just limestone and water. And what's so scary about that is this is a fossil that hasn't been seen for hundreds of million years, all the way up to when the first multicellular life emerged in the Ediacaran. Well, multicellular, because there were multicellular life before then, but it was still microscopic, like the macroscopic organisms that we could visually see and recognize as first multicellular organisms, the first plants and animals. So this is, and these fossils, these stromatolites, were seen for billions of years of Earth's history, up until the first plants and animals formed. The fact that we see them, like, this is the only time since plants and animals emerged that we see stromatolites, really shows how fucked the oceans are at this time. Like, the main things that were living were microorganisms. Yeah. Yeah. But 50 million years later, which is a long time, but 50 million years later, you couldn't even tell that any of it happened. Because life survived. Something survived. Something that was your ancestor and the ancestor of everything alive today. Something survived. And it weathered this hellscape for millions and millions of years until finally a new garden emerged. So, life, Mother Earth, Mother Nature, is resilient. And she's been here. She's been through so much worse than anything we humans could ever hope of, wreaking havoc on her. Not to say that climate change isn't a problem, a very, very serious problem, but, to life on Earth, this is nothing. It's just a problem for our continued existence, for humans. We will not survive, as well as, most of the charismatic animals that we see around, especially the big ones. They're always the ones that go first. They will, be gone, and the world we know will never look the same, but Earth will scratch that off and just like, okay, I'm a little bit different, but, those are weird, couple of dozen thousand years, but, it's fucking nothing compared to geological time. And, like, our, as bad as we could possibly make it is nothing compared to the dinosaur asteroid. And the dinosaur asteroid is nothing compared to this. So just keep that in mind when you hear, like, sixth mass extinction. That's hubris. We couldn't get anywhere close to that if we tried. But that doesn't mean it isn't really freaking bad. Because mass extinction is a kind of bad that is far beyond human, comprehension. And comparing anything that we face in this geological era is just plain wrong. And just whoever's saying that doesn't actually fully understand what a mass extinction is. But yeah, But also, think about that. We are the descendants of those who survived that. But yeah, thanks for watching. If somehow someone got this far, someone found it, that would be crazy. Yeah. See ya, whoever the fuck you are.